is going to help you understand or tell whether a number can be divided by the number 2, 3, 4, 5, 6, 8, 9, 10, 25, 50 and 100. Okay, so we're going to go through quite a few tests of divisibility. Tests of divisibility, that's a test to see whether a number will divide by one of these. You might like to get a notebook ready so that you can make a note of the things I'm about to tell you. 2, it's very obvious. All the numbers in the 2 times table, these end in 2, 4, 6, 8 or 0. They are even numbers. Okay, let's jump to 4. Numbers that divide by 4, their last 2 digits are divisible by 4, are in the 4 times table. Let me give you an example of that then. If we had a number such as 316, the last 2 digits taken together, 16. 16 is in the 4 times table, so therefore the whole number 316 is in the 4 times table. If I change that very slightly to 317, I look at the last 2 digits, 17 is not in the 4 times table, so 317 is not in the 4 times table. Let's put that back to so that you can take notes. The last 2 digits have to be in the 4 times table. How about the number 8? Well, for this one, the last 3 digits need to be in the 8 times table. Okay? You'll need to be pretty skillful at finding numbers or knowing your 8 times table all the way up to 999, but if you can do that, any number that's in the thousands or tens of thousands or millions, all you need to do is just look at the last 3 digits and it will tell you if it's in the 8 times table. Okay, other easy ones. 5, all numbers end in 5 or 0 in the 5 times table. All numbers in the 10 times table end in 0. All numbers in the 100 times table end in at least 2 zeros. Numbers in the 50 times table end in 50. The last 2 digits are either 50 or 00. Numbers in the 25 times table, the last 2 digits will always be 25, 50, 75 or 00. And then we got to get into a couple of interesting ones. And these two use a sort of trick. To tell if a number is in the 3 times table, you add up the digits, and if that number is in the 3 times table, then the original number is in the 3 times table. Let's use an example. Let's take a number like 4,261. Is that in the 3 times table? To find out, add up the digits. 4 plus 2 plus 6 plus 1. When you add those together, you get 13. Is 13 in the 3 times table? No, it's not. So in that case, 4,261 is not in the 3 times table. What do I need to change? I need to change something very slightly. What about if I change this into 4,260? 4 plus 2 plus 6 plus 0 adds up to 12 this time. 12 is in the 3 times table, so 4,260 is also in the 3 times table. It's that simple. And how do you tell if a number is in the 6 times table? Well, for it to be in the 6 times table, it has to fit the criteria of the 2 and the 3 times table. In other words, the number needs to end in 2, 4, 6, 8 or 0, and you need to be able to add up the digits, and then it divides by 3. So for this, I'm going to write in the 2 and 3 times tables. So you'll need to check that it's even and it divides by 3 for it to divide by 6. If you want to know if a number divides by 9, then you add up the digits and if the sum of the digits divides by 9, then so does the original number. So if we take a number like 81, add 8 and 1 together, you get 9, and 9 is in the 9 times table, so therefore 81 is in the 9 times table. If you change this to 8,136, then 8 plus 1 plus 3 plus 6 adds up to 18. 18 is in the 9 times table, therefore 8,136 is in the 9 times table. If I changed it very slightly, so that it was 8,135, 8 plus 1 plus 3 plus 5 adds up to 17. 17 is not in the 9 times table, therefore that number is not in the 9 times table. Okay, feel free to make a note of those. I'll pause the video for 15 seconds, but you can obviously pause it for as long as you like. Thanks for watching. Bye.